Okay, so how do we use the properties of kites and trapezoids to solve problems? Now, a kite is a quadrilateral with exactly two pairs of consecutive congruent sides, congruent consecutive sides. This means the following. The length of segment AB, whatever the measure is, let's use the number 10, is the same as AD, which is 10. However, DC, which I'm color in blue here, is not the same length as the opposite side, which is 10. DC has a different measure. All right, so DC is going to be some other number. Let's use 15 in this case, but it's going to be congruent to this, 15. They share a vertex, so therefore they are consecutive sides. So congruent consecutive sides is the way we identify a kite. Now, if a quadrilateral is a kite, then its diagonals are automatically perpendicular to each other, meaning they form 90-degree angles. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So this angle measure is going to be congruent to this angle measure. All right, so let's use some numbers to illustrate. This is 110 degrees, and this is also 110 degrees. Okay? However, A and C, these are not congruent to each other. So do not assume that these two numbers, these two angles are the same. That would be incorrect. Right? Only those pairs are congruent. All right. So how does that information fit into problems? So using the properties of kites. In kite EFGH, the measure of angle FEJ is 25. So where is FEJ? So let's start at F, let's travel out to E, and let's go over to J. So the question wants to know what's the measure of this angle right here. Let's use the question mark. All right? What information am I given? I'm sorry, I read that question wrong. The measure of angle FEJ is known, that's 25 degrees. So that's not question mark. That's 25 degrees, I apologize. And the measure of angle FGJ is 57 degrees. So once again, F going down to G over to J, that's known, that is 57 degrees. Okay, my handwriting is a little off today. Speed this up. There we go. All right, so the first question is, what's the measure of angle GFJ? So where is GFJ? So G going up to F, coming down to J. They want to know what's this measure. Well, that's the question mark. So what I know about kites is perpendicular, the bisectors are perpendicular to each other. So the bisectors, the diagonals, sorry, I can say bisectors, the diagonals are perpendicular to each other. The diagonals cut this kite into 4 triangles. So if I look at a triangle that's on the top right, and I redraw it, let's say I pull it out, it looks like this. So this point is J, this point is F, and this vertex is G. I know that my right angle is going to be right there, right? Because diagonals are perpendicular to each other. It's right there. Right? The measure of this angle is 57 degrees. The measure of this angle is known, that's 90, and the question is to find what's this angle measure. So the sum of angles in any triangle is equal to 180 degrees. So when you know 2 of the measures, so this one is 90, this one is 57, if 2 of the measures are known, we would use the following approach. 180 minus the sum of 2 known measures, 90 plus 57, will tell me what's the missing angle measure, right? So the measure of angle F in this drawing. Right, so measure of angle F is 180 minus 147. That leaves me with 33 degrees as an answer. Right. So question, measure of angle GFJ is the same as the measure of angle F in my triangle, so that's equal to 33 degrees. So I know that this is now 33 degrees. Okay, second question, part B. What's the measure of angle GFE? So once again, I do some marking, right? So it starts with J, going up to F, and going over to E. Question wants to know what's this measure? Question mark. Okay, so that measure is once again part of a triangle. So if I would draw this triangle out, say a little writing space. If I would draw this triangle out, it will look like this. Top left triangle resembles this one, where F, E, J. I know this is 90, right? This is 90 because the diagonals are perpendicular. I know this is 25, I believe. Yes. This is 25 degrees. I know this is 90 degrees. The question is asking me to find this guy. Right? So in this triangle, the measure of angle F is equal to 180 minus the sum of the two known measures. The same as 180 minus 115. So 170 minus, that's 70 minus 5, that's 65 degrees. All right. So the measure of angle F in my triangle is 65. So therefore the measure of angle JFE, pardon me, JFE is 65 degrees. Okay, so I know this is 65. Did I do that correct? No. 180 minus 1 to the 70 minus 5, 65. That's correct. Everything looks good. Great. All right. So the last question is, what's the measure of angle GHE? So G to H to E is talking about this angle measure. So that angle measure is congruent to this angle measure, right? So the measure of angle GHE is the same as the measure of angle GFE, because that's the properties of the kites, opposite angles. Those two opposite angles are congruent to each other. That's the pair that's congruent. All right, so GFE is a combination of two angles. GFE is a combination of GFJ and JFE. So the two angle measures that we found before. So this is the same as saying the measure of angle GFJ plus the measure of angle JFE. So my answer would be 33 plus 65. That turns out to be 98 degrees. All right, so my answer to this question is measure of angle GHE is equal to 98 degrees. Great. So there's some more problems. I'll go through them really quickly. In Kite PQRS, I'm asked to find the measure of angle QRT, QPS, and PSR. I'm given the information as follows. Measure of angle PQR is 78 degrees. So up to Q, up to R, this entire thing is 78 degrees. So the diagonal QS is a bisector, means that this is 39 degrees, and this is also 39 degrees. When I put these two segments together, I get 78 degrees. All right? 39 plus 39 is 78. All right, so there I have some information. The measure of angle TRS is 59. So T going up to R over to S, that angle measure is 59 degrees. I know the diagonals are perpendicular to each other, so that makes this 90, here's 90, that's also 90, and this is also 90. Okay, first question is asking me what's the measure of angle QRT. So QRT, starting at Q, going over to R, coming down to T, with this angle measure. I want to know what that is. So I'll do the same steps as before. I will take a look at this shape, the kite, and say there are 4 triangles in here, all right? So there are more than 4, but there are 4 quadrants, if you want to think about it that way. And I will draw it out. It's useful to have this diagram in front of me. Okay, so I have a 90-degree angle there. I have my letters Q, R, and C. All right, the question wants to know what this is. And I figured out that this is 39. So the same approaches, if you have 2 angle measures that are known, this is 90 degrees. In a triangle, the measure of angle QRT is equal to 180 minus the sum of the 2 known values, which is 39, plus 90. I get 180 minus 129. That takes me to 51 degrees. So this measure is going to be 51 degrees. All right, next. Find the measure of angle QPS. So there's Q, there's P, and there's S. All right. So the measure of angle QPS, this side, which is congruent to this. Right? Because opposite, there's one pair of angles are congruent. So QPS is congruent to QRS. So the measure of angle QPS is equal to the measure of angle QRS. And we know some stuff about QRS. QRS is made up of two pieces, right? QRS is made up of this piece and this piece, right? So QRS is composed of QRT and TRS. So therefore the measure of angle QPS is the measure angle of QRT plus measure of angle TRS. The space, that's a little bit better. TRS. Right? So we have those numbers. QRT is 51, TRS is 59. That's going to be 110 degrees. Okay, final question. What's the measure of angle PSR? So PSR, starting at P, going over to S, going up to R, we're looking for this angle measure. Now, there are a number of ways of doing this. We could take a look at individual triangles, and that's the approach I'm going to use. I'm going to say, well, I'll pull the triangle in the top right corner off, so and redraw it because my diagram is getting kind of hectic with all these marks I've placed on it. So it's kind of useful to sketch out a fresh triangle that doesn't have all these markings. So there's R, there's S, and there's T. I know at T there's a 90-degree angle because the diagonals are perpendicular to each other. I have to find this measure. I don't know what that is, but I know that this is 59. Okay? So if this is 59 and that's 90, it's easy to find the angle TSR, right? So the measure of angle TSR is the same approach we've been using, which is 180 minus the sum of the two known measures, 59. So that's 180 minus 149. So that's equal to 31 degrees. Now the question is not asking me what's the measure of TSR, it wants to know what's the measure of PSR. So measure of PSR is a combination of TSR and PTS. These two things, these two angles, when put together, would give us PSR. I know those two measures are congruent to each other, so I could say the measure of angle PSR is equal to, well, what did I just call this? TSR plus PST. Angle PST. Right, so they're both the same measure, so that's 31 plus 31 is equal to 62 degrees. Now, there's another way of doing this, or looking at this. You could have said, well, if I know that this is 31 degrees, and these two angle measures are congruent to each other, I could say 31 times 2 is equal to 62 degrees. I could have just used multiplication instead of addition. Either way will lead you to the correct answer. There's a third possible way of doing this, and that would be to look at this entire top as a single triangle. Let's call this the top. That's congruent to the triangle beneath, and then we would use the same approaches. I know this measure is 39. I know this measure is 110, so it's easy to figure out that this was 31 by using the same approach. If that's 31, then we add these together, or we multiply by 2 to get to 62 degrees. Any of these approaches will be correct. There's no standard way of proceeding from that point. Okay, we're moving on. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides is called a base. So for example, how do I know which sides are parallel in this given diagram? Parallel sides are indicated with these arrow marks. So I know that this line segment is congruent to this line segment. Not congruent, parallel, pardon me. They're parallel to each other. Meaning if I would continue these lines forever in both directions, they will never touch each other. Right? So the sides that are not parallel to each other are called legs. Right? So this will be a leg, and this will be a leg. The sides that are parallel to each other are called bases. So that's a base, that's a base. Right? So the angles that are, each of the parallel sides are called a base. The non-parallel sides are called legs, which we already indicated. Base angles of a trapezoid are two consecutive angles whose common side is a base. So, for example, this we said before was a base. Let's change the color. We agreed that this was a base, but that's one of the parallel sides, right? So the angles that are sharing that side are known as base angles. Right? So this is another base, and the angles that are sharing that side are known as base angles. Right? So if the legs of a trapezoid happen to be congruent, they happen to be the same number, the trapezoid is classified as an isosceles trapezoid with some theorems associated with it. Let's take a look at those theorems. Now, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are automatically equal to each other. They're congruent. So that means I know that this is a parallel trapezoid. I know that it's an isosceles trapezoid because of the tick marks telling me the legs are congruent. So therefore, the base angles have to be equal to each other. So whatever this number is, if this number is 60 degrees, for example, then this angle has also got to be 60 degrees. Right? Looking at the other base, BC, if I know this angle measure is 120 degrees, for example, then this has got to be also 120 degrees. Second theorem, if a trapezoid has one pair of congruent base angles, then it's automatically isosceles. So if I have no further information, if I'm told that, well, these two guys are the same, right? So like once again, this is 45, this is 45. If that's all information I have, I know that this triangle is an isosceles trapezoid because those two base angles are congruent. Once the base angles are congruent, the reverse is true, right? The trapezoid is isosceles. And the final fact is the diagonals of the trapezoid are automatically congruent to each other. All right, so if I know AC it has some value, some numerical value of, let's say, 200, then BD is also going to be equal to the same number, 200. They're congruent to each other when the trapezoid is isosceles. So when we apply those three facts, we get problems. It helps us to solve problems like these. Find the measure of angle y. Well, I know the measure of angle y is up here. I know this is an isosceles trapezoid because the legs are congruent to each other. If the legs are congruent to each other, then the base angles are congruent. So x must be equal to y, and w must be equal to z. So I know from that fact, z is 117 degrees. But that doesn't really help me because I have to find y. I have no number to x or y. But there's a way to figure that out. There's two ways, in fact, and I'll show you both ways. Step number one. It's a quadrilateral, so the sum of all the angle measures in a quadrilateral must be equal to 360. So if I add measure of angle x to y to w to z, I would get w plus x plus y plus z is equal to 360 degrees. I have some numbers I could replace these guys with, right? And there's some stuff I don't know about. So let's call this angle x degrees. And we know it has to be x degrees over here because they're congruent, right? So I get w, which is 117, x, which is x, y, which is also x, and z is 117. Combining like terms, I get 2x plus 234 is equal to 360. Subtracting 234 from both sides, I get 2x is equal to 30 minus 4, it's 126, I believe. I'm just doing this in my head, I might be a little bit off. Divide both sides by 2, x is equal to 63 degrees. All right, so the measure of angle x is 63 degrees, and that will be the measure of angle, x is equal to 63, pardon me, so the measure of angle y, which is x degrees, is 63 degrees. So that's one way of doing it. Another way of doing the same problem is looking at this leg. All right, I'm looking at this leg right here, YZ. And these two angles are sharing that side. I know they're not congruent to each other, but I know that they must be supplementary. So the measure of angle Y plus the measure of angle Z must be equal to 118 degrees. And I can get them away from me, give me a second. So the measure of angle y, I'm searching for this, plus the measure of angle z is 117. Okay. Subtract 117 from both sides. Okay, the measure of angle y is equal to 63 degrees. So either approach will get us to the same answer, and that'll be correct. Next, I have the following. I have an isosceles trapezoid. How do I know it's isosceles? Well, once again, the legs are congruent. I know it's a trapezoid because there's one pair of parallel sides. If this setup is true, then we know the diagonals are automatically congruent to each other. So the question wants to know what is the length of ES. I'm going to crooked as we do it. Right. I'm given that RT is 24.1. This entire leg line segment is 24.1. QP is 9.6. So this segment in red is 9.6. Right. So the facts are QS and RT are congruent to each other because that's one of the properties, right? So QS is equal to RT. So that makes QS equal to 24.1. I know that QS is the sum of two pieces, right? QS is made up of two line segments, so it's QP plus PS. Okay. I could replace QS with a number, 24.1. I could replace QP with a number, QP is given as 9.6, and I'm searching for PS. PS is the goal of the problem, find PS. Okay. So subtract 9.6 from both sides. You need a calculator to help me out, so I'll pause. Okay, so that turns out to be 14.5. 14.5 is equal to PS. Let's write it out here. You can see it a bit better. So PS is equal to 14.5. That's my answer. Okay, so we have two more problems of the same type. Let's do them quickly. Find the measure of angle F. I know angle F is congruent to angle G because this is an isosceles trapezoid. I know angle E is also congruent to angle H for the same reasons. So GH is a line segment that's being shared by these two angles, and so is EF. EF is being shared by angles E and angles F. I know the measure of angle E is 49 degrees, so I can put that into my sketch. Now, the measure of angle E plus the measure of angle F has to be equal to 180 since they are sharing this side. They're sharing this segment, this leg. All right. So measure of angle E is known as 49 degrees. Measure of angle F is what I'm searching for. That's the goal of my problem. It's equal to 180. Subtract 49 from both sides. I get the measure of angle F as that's 140 minus 9. It's 131 degrees. Answer to my question. 3B. I have Jn being equal to 10.6. So that's 10.6. I have NL being equal to 14.8. 14.8. So JL is equal to JL is equal to the sum of those two pieces, right? Jn plus NL. I have numbers for Jn and NL. Add this together, JL is going to be equal to 10.6 plus 14.8 is equal to 25.4. Right? So JL is 25.4. The question is asking find the length of Km. All right, so Km is the other diagonal of this isosceles trapezoid. I know the diagonals of isosceles trapezoid are congruent, so that makes Km equal to JL. So Km is also 25.4 feet, inches, yards, centimeters, whatever the unit of measure is. Okay, so applying conditions for isosceles trapezoids. So find the value of y such that EFGH is isosceles. Right? So to make this thing an isosceles trapezoid, I know that these base angles have to be congruent to each other. So the only way it's going to be an isosceles trapezoid is when the y value is a certain number. Right? And let's find out what that certain number is. If it's going to be isosceles, then measure of angle E must be equal to the measure of angle H. So I could go ahead and replace those with values. I go 2y squared minus 25 is equal to y squared plus 24. I combine like terms by subtracting y squared from both sides. I get y squared minus 25 is equal to 24, because these cancel out. Add 25 to both sides. I get y squared is equal to 49, because these 25s cancel out, right? So if y squared is equal to 49, then the value of y must be the square root of 49. So y must be equal to the whole number of 7. Question wants to know what's the value of y. It doesn't ask me to substitute anything. The value of y is equal to 7. Okay. JL is equal to 5z plus 3. So JL is this diagonal. Okay. Km is 9z minus 12. So Km is this diagonal. So JL was 5z plus 3. Let's write that in. And Km was 9z minus 12. Let's write it over here. For this triangle to be isosceles, these diagonals have to be congruent to each other. So I could say JL is equal to Km. Let's make this, give myself a little room to write. So JL is equal to Km. I can replace JL with the expression 5z plus 3 and Km with the expression 9z minus 12. Once again, just like before, we do combination of like terms. We combine like terms. So I subtract 5z from both sides. I get 3 is equal to 4z, take away 12. Add 12 to both sides. I get 15 is equal to 4z, right up here. 4z is equal to 15. Divide both sides by 4. Z is equal to 3.75. Question is wants to know what's the value of z. Doesn't want us to substitute anything. Z is equal to 3.75. Okay. So once again, same type of approach. Find the value of x such that PQST is isosceles. That means the measure of angle Q must be equal to the measure of angle S. So for this triangle to be isosceles, this must be true. Okay, so we go ahead and say measure of angle Q is 2x squared plus 19. The measure of angle S is 4x squared minus 13. We combine like terms by subtracting 2x squared from both sides. I get 19 is equal to 2x squared minus 13. Add 13 to both sides. I get 19 plus 13, that's 20, 32. 2x squared. Divide both sides by 2, I get x squared is equal to 16. If x squared is equal to 16, it means x is equal to the square root of 16. X is equal to the whole number 4. Okay. So the midsegment of a trapezoid is a segment whose endpoints are the midpoints of the legs. All right. So in lesson 5-1, we studied the triangle midsegment theorem. The trapezoid midsegment theorem is similar to it. All right. So if you can't remember or you have never seen the triangle midsegment theorem, it looks like this. X is the midpoint between A and B. Y is the midpoint between C and D. How do I know it's a midpoint? Well, XB is congruent to AX, and CY is congruent to YD. So that makes these points the midpoint. When you connect these midpoints, these dots, you get a line segment that's known as the midsegment. Right? So the length of that line is half the sum of the two bases. So if this was 10, and this was 8, for example, then we would add those two measures and divide by 2. So 10 plus 8 is 18. 18 divided by 2 is 9. All right? So that's the trapezoid mid-segment theorem. So let's take a look at some problems associated with it. Find the length of ST. So I know that MN is giving us 31 and RU is giving us 38. I have to find ST, right? Question mark. So the trapezoid mid-segment theorem tells me that MN is half the sum of ST and RU. All right? So MN in this case is 31. ST, I'm searching for it, and RU is given as 38. So I need to solve this. And the quickest way to solve this is as follows. If I have a fraction, I'm going to multiply by the reciprocal of that fraction. I'm going to multiply by 2. It's an equation, so what you do to one side, I do to the other side. So 2 times 31 is 62. 2 times 1/2, well, they cancel each other out, leaving me with ST plus 38. Right? So I'll multiply by the reciprocal of that fraction. Solve for ST, I'll subtract 38 from both sides. I get ST on this side. 62 minus 30 is 32. 32 minus 8 is 24. My mental math is correct. All right, that looks right to me. So ST is quite simply equal to 24. Just have to confirm my math. All right, so that's it. ST is equal to 24. Another problem, find EH. So XY is equal to half the sum of FG and EH. Now, I know you guys are tempted to go ahead and start putting in numbers right away, but I encourage you to write the theorem out in letters before you make your substitutions. It gets less confusing that way. Now, all I need to do is substitute, right? So XY, pardon me, is 16.5. That's a half times FG. FG is known, that's 25. EH, I'm searching for it, so we leave those letters in. The approach is the same. Multiply this entire thing by 2. Multiply this side by 2 as well. So 16.5 times 2 turns out to be 33. A half and the 2 cancels out each other. So what's left is 25 plus EH. Subtract 25 from both sides in my next step. I get EH is equal to, quite simply, 8. EH is equal to 8. Well, there's another approach to doing these problems, but it's not as solid. It gets you to an answer really quickly, but you need to show the work as to how you get there. So the other one is kind of like it skims on the work, but there's a shortcut. All right, so here is a shortcut. If I know FG to XY was a reduction in size, right? So from 25 down to 16.5. I asked myself, what's the difference between those two numbers? So I do 25 minus 16.5, and I get 8.5. So I went down by 8.5 to get here. So to get down to the next line segment has to be decreasing by the same amount of 8.5. So I do 16.5 minus 8.5, my answer is 8. If I look at the previous problem, we'll notice the same thing applies. How do I move from 38 down to 31? Well, I went down by 7. If I move down by 7 again, I'll wind up at 28. Or 24. 24. Right? Because 31 minus 7 is 24. So it kind of like does a shortcut and it gives you the right answer, but you have none of the theorem to back it up. And if you're asked to show work, this doesn't hold. This doesn't hold on an exam. All right. Well, that's it for the lesson. I encourage you guys to look through the class notes and answer these summary questions. Is it possible for the legs for trapezoid to be parallel? Explain How is the mid-segment of a trapezoid similar to the mid-segment of a triangle? How is it different? So I'd like you guys to take a look at that and answer those questions on your own. But that's the end of the lesson. I hope you guys enjoy the presentation, and I wish you the best of luck.